we're going to take you back to day one and we're going to talk about numbers, okay? The structure of the lessons are always the same. We'll have a title screen and then we'll talk about the objectives. So today our learning outcomes are to define and use integers to deal with place values. Some of you are sitting there, what's an integer? We'll find out very shortly. We're going to add, subtract, divide and multiply any number. And we're going to use and manipulate number operations. And rounding an estimate of integers is the final thing. That's a nice little thing at the end that we're going to do. Okay. The little red letter and number N1.1 refers to that AQA specification. So when I prepare the lessons, I cross-reference it to that to make sure I don't miss one thing. So when you get to the exam, there are no surprises. We've covered everything. Okay. I'm going to put this up every week. So today's week 1. Last week was a bit of a week 0. So today is numbers. It's green because it's in Unit 1, blue because it's in Unit 2, and red because it's in Unit 3. And as we said, we're going to do Unit 2 first. In other words, we're going to do all the blue first because it's got most in common with the other units, and then there's only a couple of things on its own, and we've done Unit 2. So by the end of November, beginning of December, we'll finish Unit 2, and we'll do a Unit 2 practice paper, and you'll be amazed at how good you all are. Ground rules that we agreed last week, so we had a little bit of an exercise. Attendance and punctuality are 2 at the top. Okay, lessons. You've entered a no calculator zone. Basically for the next 5-6 weeks while we're doing the basics, because it's Unit 2, it's the no calculator paper. Everything I give you shouldn't require a calculator. I'll try and give you questions at the level they will give you in a Unit 2 paper. If it gets any harder than that, it will be from Units 1 and 3, and you can use a calculator. And that goes for your homework as well. I have no issue with you checking your answers with a calculator, but from about week 6 onwards, we can get your calculators out and start playing with them. Okay, so to start off, we're just going to do a quick history lesson on numbers. The history of numbers. What numbering system do we use day to day in our lives? Decimal system, yeah. Base 10. When we get to the 10th thing, we give another digit, okay? It's called the decimal system. And basically, the Egyptians, about 3,000 years ago, were using a decimal system, but with symbols, okay? More recently, the Greeks in 500 BC, bless them, not only philosophers, but they did a lot of studying with mathematics, and you'll hear a few of their names as we do it, also had a decimal system, okay? It's a system of numbers that has 10 digits. What's the thing that's missing on these two systems? What have they not got? 0. Perfect answer. 0 is missing. They didn't have a 0. So if they were saying, I don't know, the number 11, they'd have that. But how do you know the difference between 11 and 201? So 0 was missing for their systems. 0 is a very, very useful number. And our numbers, commonly known as Arabic numbers that we use day to day, this numbering system, even though we call it Arabic and we call them Arabic numbers, actually came from India, via India, around 1000 BC. And we've got evidence to state that not only were the Indians using zeros, they were also using fractions and decimals well before anybody else. The reason we change at 10 is because we've got 10 digits. So it was really useful to change at 10. So we do groups of 10 because we've got 10 of these. Okay? The abacus with its 10 little beads. Okay? Really useful thing because the digits mean something depending on where they are. So if we look at our numbering system, and all of you have probably seen something similar to this, we start down on the right hand end with our whole numbers and we count 1, 2, 3, 4, 5, 6, 7, 8, 9. But when we get to 10, we have to use another digit plus that wonderful 0. The 0 is called a placeholder. It means there's nothing under that particular column. So here, if we put a number down, 203, it would be 203. So the 0 is what we call a placeholder. It's a really useful thing, 0, that we mentioned earlier. Okay. GCSE maths, you're expected to deal with numbers into their billions. That's why I put it up there for you. Okay. So they generally don't ask you questions like, what's this value, and fill all those numbers up. They'll ask you along the lines of, write this number down in words. kind of thing. Okay, so you do have to realise what the place values are for numbers, generally up to about here, and then when you deal in millions and billions, you leave them as million billions. So if I said 6 billion plus 2 billion, it's 8 billion. Don't have to put all the zeros on, add them together and then call them something, yeah? Okay, so let's have a look at that a bit closer. So here's a perfect example of the first type of question you're going to get in the exam. Okay, we can categorise our numbers. So we've got our numbers and we know how our numbers work. We can categorise them into odd and even. So how would you define an odd number? What's a good definition of an odd number? Brilliant. Something that doesn't split into two. So when you got a number and you try and split it into two, which is that, isn't it? Yeah, divide it by 2. It goes in, but there's a remainder, isn't there? It doesn't go in exactly. So what's a good way of, a good definition for an even number then? It divides by 2, exactly, yeah? Or what does it end in if it divides by 2 to be even? So I don't care what's in front of it. I could add 83,473,627,842 and it's got to be even. Yeah? So all I have to do to check an even number is that last digit. Happy? You're thinking, oh, this is so basic. But trust me, you'll get questions on it. Okay? So here's another one for you then. They've given you 4 cards. This is question 1 in another exam. They've given you 4 number cards. They want you to work out what the smallest number is using those 4 cards. And then the second bit equates to what is the largest number using all 4 cards, but that number has to be even. Have a go at those 2. Front lefticals. What have you got for that one then? What is the smallest number?
3,567.
Everyone understand that? Everyone get that? Yeah? So we're just rearranging them, and it's about place values. That's what that question's about. Largest even number, front righticals. What have you got? What's the largest even number? 7634. Everyone get that one? Yeah? No? Okay. Don't beat yourself up. That's correct. Okay? So the biggest digit is 7, so it's at the front. We want to create the biggest number we can. We've got to keep one of the 2 even numbers for the end to make it even. So you keep the smallest one there, so you can put the bigger one further up. 7, 6, and that just leaves 3 and 4. And they're the sort of questions that they'll give you very early on in the exam. These should be the get these marks in, boost your confidence type questions. Okay. So, who's brave enough to come up? You have to know the order of numbers. Sometimes they'll ask you to sort numbers, or spot the highest number, or spot the lowest number. So get used to the technology, especially those of you who want to become teachers. Help him out if you want to. Group activity, doesn't rely on one guy. Okay? Happy? Everyone agree? Okay. So this word integer, it was the thing that was in our first objective, to define integers, okay? What is an integer? What do we think it is? You heard it before? If you get a maths question, circle the integer.
It's a whole number.
It's a whole number. What else about it? It's a whole number, quite correct. And there's something else, a little add-on at the end.
It's just the minus as well. It's
Brilliant.
Negative.
Brilliant, brilliant. Whole number, that can be positive or negative. So an integer basically is all your positive numbers and all your negative numbers. Up to now we've just talked about the positive numbers, haven't we, when we're talking about our numbering systems. Well, these numbers can be negative. Now be aware that when we talk about positive numbers, there's an invisible plus in front of them. But it would be really, really boring if we kept putting pluses in front of positives. So when you look at a positive number, they're positive because they've got nothing in front of them. But to be negative, they must have that minus sign, okay? Something to store away for a rainy day, that one. So, now we're talking about buzzwords. And one of our first buzzwords that we'll collect here for our glossary of terms, in an exam, you could quite easily get a question that says circle the integer. If you don't know what this means, you can't answer the question. It's a mark out the window, an easy mark, just because you know the definition of a word. Back righties, which one's the integer? Brilliant. Minus 3. Yeah, that's the integer. Okay, so let's talk about negative numbers for a minute. What is the definition of a negative number? Brilliant. Anything that's below 0. It doesn't have to be a whole number. If it was a teeny bit below 0, we define it as a negative number. Okay? So we've got positive numbers going that way, and we understand that positive numbers get bigger. What you need to realise is that when you start heading this way down the number line, so our zeros here, the bigger the negative number, the smaller it is. Yeah? So minus 10 is smaller than minus 2. Even though the digits 10 look bigger, because it's negative and it's going that way, when you're sorting negative numbers, if you're further to the left, it's a smaller number. So minus 10 is smaller than minus 2. Okay? Very important to take that one off. Right, so where do we come across negative numbers in day-to-day life? Winter, good. Temperatures, absolutely perfect. Yeah? Where else? Yeah? If you're like me, married, yeah, always got an overdraft. Golf, under par, when they talk about golf championships. Depths of water, that can be negative. Yeah, if you're talking about a level of water, you can have negative depths. Okay, so we come across negative numbers quite a bit, and we're going to have to learn how to deal with them. Anyway, so there are all these words we use in accounting that you might need to know in a question, because they could give you a bank account and tell you to balance it. Okay, and you have to know what debit and credit means. So an account is credited with £50. Do I add it or do I take it away? There are a lot of words associated with bank accounts, and what they can quite easily do is that. Unit 2, November 2012, question 3, so quite early on. Okay, so let's do it together. I've got £97 as a balance. In other words, that's my starting number. On the 12th of September, cash 85 credit. What am I meant to do with that 85 then? I'm going to add it. So 85 plus 97. Brilliant. I've taken away the decimals. I made it easy. We don't deal with decimals for 2 weeks, so I made it nice and easy. I got rid of all the pence. Okay. £162 under debit. What have I got to do there? Take it away. Leaves me with. Oh, I'm hanging in there. Okay. Oh no, electricity bill. Minus 60. And we'll come on to negative numbers in a minute. So I'm £60 overdrawn, and that's when all the fees kick in if you haven't arranged the overdraft and blah, blah, get a bit complicated. Okay? But that's an example of how they could ask you straightforward questions about numbers, but using banking terminology. You need to know credit, debit, balance, and how to use them, okay? Right. And really, that's the first objective. We're flying through half an hour in, define and use integers to deal with place values. So all we've really talked about are the numbering system, but we know where things are in that numbering system, and we know 0 is a holding number, okay, a placeholder. We're going to get onto the interesting stuff next. Okay, we're going to start talking about adding, subtracting, multiplying, dividing, but we're only ever going to do that today with whole numbers. It doesn't get nasty until next week and the week. Okay? So the rules of number. Can everyone see what the rules of number are? Adding, subtracting, multiplying and dividing are what we call the rules of number. These are the things, the basic things that allow us to manipulate those numbers we were talking about. And they're related. I mean, how are these two related? Plus and minus. In what way are they related? 6 plus 2 gives us 8. Okay, and if I take the 8 and I take away the 2, it takes me back to where I started. So these two are related, and they're opposites. Okay? How's plus and multiply? How are these two related? What's multiplication?
Just plusing by.
Yeah. So 3 times 2, everybody knows, is 6. And all you're saying is, I want to add 2 to itself 3 times. So plus and multiply are related because this is a multiple event of them. It's lots of them to get this. That's all it is. You might not have thought of this. How are subtraction and division associated? If I say to you 8 divided by 2, hopefully everyone will say 4. So, can you see how these two are related? If I have 8 and I take away 2 and I do it again and I do it again and I do it again, it takes 4 goes. So it's a multiple event again. So division is actually multiple taking aways. Have anyone thought of it like that before? No? Okay. And then these two are related. How are these two related? What's the relationship between multiplying something and dividing it? Opposites. So what you end up with is this relationship between our basic functions. Inverse is a posh word for opposite. Okay? So addition and subtractions are opposites. Addition and multiplication. Multiplication is repeating addition. Division is repeating subtraction. And multiplication and division are inverses. They're the opposites. Okay? So even before we start introducing numbers, we've got a relationship between these functions that we use in mathematics. Okay? And all we're going to do is we're just going to stick numbers in for these functions. So let's start off with the basics. Let's do some addition then. What is the result of doing an addition? That's a word we use. It's a little one. When I was little, whenever we did maths, it was always maths sums. But the answer to an addition question is called the sum. It's very specific. So if I said to you, what is the sum of 4 and 5? You need to know that you've got to add them. So a sum is another word for plus. That's what sum means. See why I'm saying this in a minute when I give you the definition for the others. Okay? So let's have a look at addition. Right, so we use the column method for those of you who are rusty on it and like to use it. 298 plus 137. So essentially you're lining up the ones, the tens and the hundreds. And then you need to add them. So 8 and 7 is 15, 9 and 3 is 12, plus the one I carried over is 13, 2 and 1 is 3, plus the 1 is 4. So your answer for the first question should look something like that. Okay, so the answer to a subtraction question is the difference. And that's how they'll word it. What is the difference between this and that? So it's another one of these buzzwords that you need to know what it means, because it's the proper word for the result of a subtraction question. Okay. Right. Do you want me to show you how to use the column method for this? Column method, exactly the same as before. You need to line up with units with units, tens with tens, hundreds with hundreds, okay? And then you need to take them away. Now, if you take them away and there aren't enough, you've got to borrow them and carry over. So 4 from 1 didn't go, I borrowed 1, 4 from 11 is 7. 6 from 2 doesn't go, that becomes a 7 because we've borrowed 1. 6 from 12 is 6, 2 from 7 is 5. Everyone get that? Yeah. This is a question 1, question 2 type question, okay? Work out that. That's 2 marks in an. So you can put anything in here you want. So if you want to line them up in here yourself, should end up with that. If you leave it like that, you've lost a mark. Because if you don't put the answer on the answer line, you don't get the mark. So, 1 for showing you're working out, 2 for putting the answer on the answer line. Okay? And you'll get reminders of this when you do your assignments for me and everything else. Is everyone happy with this level of maths? Yeah? Thank goodness. Thank goodness. So here they're starting to mix a few things up. They're asking you to do a bit of a sort. Can you tell them which is the cheapest, the expensive? And then this is probably not the biggest numbers, but how you deal with taking away with big numbers. Have a go at that first one. Which is the cheapest house? D? Everyone happy? Yeah, so can you sort big numbers? Most expensive? 8. And the difference for 2 marks. Okay, that's 1 mark. So providing you've done something up here to earn that mark, to show them how you've done it, you could say A is 500 above 132,000 plus the 250 that's below it, anything like that. Or if you do the column method, however you want to do it, that's fine. Getting funny faces, Paul. Everyone use the column method? Yeah? Okay, use the column method. So you've got 132,500 and you've got 131,750. 0 from 0 is 0, 5 from 0 doesn't go, you've got to borrow 1, 5 from 10 is 5, 7 from 4 doesn't go, 7 from 14 is 7, and they all cancel each other out. Okay, so it should look something like that you're working out. Okay. Lots of smiles and nods, don't worry, you'll be crying in a minute. Multiplication. I had to learn these rote learning when I was younger. I used to stand up there and 4 fours are 16, 5 fours are 20, so on. You need to get your head around your times tables for Unit 2 because you're going to have to do multiplication and division at some point. And division is, like we said, the opposite of multiplication, so the better you know your times tables, the quicker it is to do division. The answer to a multiplication question is the what. What is the proper posh word they use to say, I want you to multiply these two. There's always one. The product. So, you will get questions in the exam that talk about this thing called the product. The product of two numbers means they want you to multiply them together. So again, it's a buzzword. The product. The answer to a multiplication question. There's lots of ways to ask you questions on multiplying. They could say, by 3 by 4. You know, when you used to talk about planks of wood and stuff, 3 by 4. It means multiply the length of 3 by the length of 4. Yeah? So you've got product, you've got by, you've got multiply, you've got times. So there's all these words that mean this thing here. Okie dokes. Right, let's try 58 times 7. Anybody want to show me how to do that? No? Okay. The first method is the column method. Okay? So if I've got 58 and I line up the 7 with the 8 because they're the units, all I need to do is go along and multiply each of these by that number. So 7 times 8 is 56. Well, the 5 is 10, so I put it over there, carry the 6. And 7 5s are 35, but I've got another 5, so it's 40. Okay, so the column method, you go along and you multiply each column by that digit. So 7 8s are 56, 56, 7 5s are 35, plus the 5 I carried over is 40. So 40. Okay, so that's the column method. A lot of people like the column method. I'll show you the other methods in a second. This one here, this 600 times 30, there's a real quick and easy way of doing this because it involves tens and hundreds. Anybody like to tell me what it is? 18th. And how did you get that really quickly? Brilliant. So you've got 1, 2, 3 zeros. Take them away, forget about them. Do the simple sum, which is 6 times 3, which is 18. And then bring your 3 zeros back. 1, 2, 3. And it saves lots and lots of rows doing that. And that was the learning point there. So if you get numbers with lots of zeros, get rid of the zeros, do the easy sum, put the zeros back. Right, let's look at the other methods, okay? So I've put a question up here, 42 times 35. We're going to look at the 3 methods for that. Have a go if you want to. If you don't, I'm going to go through it slow time for you, okay? So let's look at the column method. So if I've got 42 times 35, I need to line them up. So we're going to start off with the 5. We're going to start off by multiplying the units by everything up there. So 5 times 2 is 10. So it's 1 and the 0. 4 5s are 20, plus the 1 I've got there is 21. Can you see what I've done there? So I've used the 5 and I've multiplied the 2, then I've multiplied the 4. Don't worry if you don't like this method, the other methods might be for you. Now we've got to do the 3. Now the 3 isn't a 3, it's a 30, isn't it? On our place values. So if it's a tens, you've got to put a 0 there before you start, because that's 3 lots of 10. And then you go along and you multiply each of the digits. 3 times 2 is 6. 3 times 4 is 12. The two columns that you have there, you have to add together. 0, 7, 4, 1. That's what we call the column method. That's how I was taught how to do it. I had to learn these other two methods, okay? I personally think they're easier than the column method. So the first method is called the grid method, and you break the numbers into their chunks. So 42 is made up of 40 and the number 2. 35 is made up of 30 and the number 5. Can you see that? See what I've done there? Very clever, isn't it? My tens are my units, my tens are my units. All you need to do then is multiply them across as they appear. So 40 times 30, I just showed you a quick trick on how to do that really quickly. What do we reckon it is? What's 4 times 3? 12. And then how many zeros did I forget about?
2.
So I have to put 2 back. 30 times 2, 60. I can forget about the 0, do the 2 times 3, which is 6, put the 0 back. 5 times 40, plus the 0 I took away, okay? And then 5 times 2. So in this box I've got all the numbers when I do all that cross multiplying. All I have to do now is add them. So 1200 plus 200, 60 plus 10, add those two together. You see how that method works? And a lot of people prefer that because the biggest numbers you have to multiply is 9 by 9. All the rest of it is taking away zeros and putting the zeros back, isn't it? I quite like that one. This is the one, when I did my Bolton Uni course last year on numeracy, that they were trying to push. This is the one that everybody's going for now. This is what they teach at school. So you might like this one to show your kids how to do it. It's called the lattice method, okay? Just like the grid method, you split them up, but all you say is 42 and 35. Okay, so you split your number up like this, and it works for bigger numbers, it works for decimals, it works for all sorts. Then all you do is the multiplications across the way. So 4 times 3 is 12. So the tens go in there, the units go in there. 3 times 2 is 6. So I've got no tens, but 6 units. 5 times 4, 20. So 2 tens and no units. And 5 times 2, 10. So you've done, and again, the biggest numbers you'll multiply is 9 by 9, isn't it? So you only have to know up to your 9 times tables. Then to get the answer, you kind of extrapolate these. So you go down each of the diagonals. So you go down this diagonal, you've got 1. You add them together. You go down this diagonal, 0 plus 2 plus 2, 6 plus 1 plus 0, and then 0. So it's 1, 4, 7, and that's what they're using in schools. Okay? So there are 3 methods for doing multiplication if you struggle with multiplication. So as we said, when you multiply by 10, we're sticking a 0 on the end. So if we had this number here, we multiply by 10, we're just shifting everything along that number line, aren't we? Yeah? In our columns. And if we do 10 again, you move it by 10 again. And that's really useful for doing those techniques. I'm going to win hand now. Right, this is it. The one I win before the break. Right. So we've got. So the answer to a division question is the what? It's the quotient. Right? You will never be tested on that. They won't say what is the quotient of these two numbers. They will test you on product, difference and sum. I'll put it here, but I've never seen it ever in an exam. The word quotient, that's never appeared in an exam, okay? And I wouldn't expect it to. It's a real specialist word. Divided, split 4 ways. They'll use words like division and so on, okay? They're not going to use quotient. If they do, you lot have lucked in. Okay, division questions then. Going to get you two divisions. Trying to keep it easy for now. Everybody happy with a technique for doing division? If you're not, we'll show you. Okie dokes. Again, our square paper comes in useful. So let's show you the technique first. So I've got 75. So 75 is here, and we call it the bus stop method. We put what's being divided into the bus stop, and we divided it by the number doing the dividing outside the bus stop. Okay, and all we say to ourselves is, how many 5s go into 7? 1. Remainder 2. Okay. As long as you know what you've done. We learn by mistakes. No bad thing in mistake. So I've now got 5 and I've got 25. How many times is 5 going to 25? 5 times. So that's what we call the bus stop method. It's the generic way to do division. It's the best way to do it. Okay? You could do it by lots of taking away. 75, take 5, take 5, take you forever. You haven't got that time in the exam. Let's have a look at the other one then. If we look at... Oh, I haven't done it. I'll re-scribble it. So 72 divided by 4. So we've got 72 goes in the bus stop, 4 outside the bus stop. That's what division means. 4's into 7, remainder 4 into 32, 8. And that's where your times tables comes in. Can you see these things really quickly? Okay, everyone happy with division? Fantastic. Sometimes they'll give you divisions and they'll talk about what's left over. Called it the remainder. Okay. So, if we look at this one, 8 divided by 3, it goes how many times? 2, remainder 2. Okay? There's nothing wrong with remainders. We talk about remainders at GCSE level. You think it's a bit simplistic. But I'll show you a question in a minute where you actually need to use the remainder for something. And the remainder means something. And you'll see that next week when we talk about fractions. Okay? 43 divided by 4. It goes 10 times. Yeah, because 10 4s are 40, and straight away I can see I've got a remainder 3. And you're thinking, oh, blimey, that's a bit simplistic. But they'll ask you questions like that. 10 people need to catch a taxi to the airport. A taxi can take 4 people. How many taxis do we need to get everyone to the airport? So they're asking you to do that, and you know it goes in twice, so you've got 2 full taxis. Remainder 2. So you need another taxi for the last 2 people that are left over. And that's how it translates into a question in the exam. You're talking about remainders, you don't realise you're doing it. Okay, good. And again, dividing by 10, you're knocking the zeros off. Next, in 2 weeks' time when we talk about decimals, we'll see what happens when you then divide that by 10. Okay, the decimal place starts kicking in. Well, we're not covering that today. Everything is integers, whole numbers today. Okay. If they give you questions on billions and millions, what you're not meant to do is convert them into zeros. So I know 6 billion is that. I'm not going to do that in the exam. I'm going to add 6 to 2 and call it billions. So when I add 6 billion and I increase it, so it's another way of saying add, by 2 billion, I know it's 8 billion. Number of times early on in a course, I'll see people put in all these long, don't. If they give it to you in billions, then do it in billions. Same for millions, 4 millions, and I split it, so that's division, 4 ways. So I'm saying 4 divided by 4 is 1 million each. Okay? So don't make questions complicated when they don't need to be. That's my advice to that bit there. Like I say, full of good tips, aren't we? Integers exercise. I'll tell you what, memorise those. Now tell me the answer to this. Can you make... No, I'm joking. I've got a handout. So now we've got our rules of number, our adding, subtracting, multiplying and dividing. But we're going to add it with a twist. We're going to talk about it with respect to negative numbers. And earlier on you said to me one of the ways we talk about negative numbers with temperatures. So best way to visualise negative numbers is with the number line. I know it sounds quite basic, but even with a master's degree, to keep myself straight with negative numbers, I visualise, I close my eyes, and I think of this number line and where things are on that number line. So if I was going to say, you know, what's the difference between Paris and London, I'm just taking 4 away from 7. It's a 3-degree difference. As soon as we start introducing negative numbers, everybody seems to go to pot. So if I said to you, what is the difference in temperature between Moscow and London, then all you need to do is visualise this and say, well, I'm -3 down here, I'm 4 up there, so I've got 3 to 0, another 4 that way, and I've got a 7-degree difference. Okay? So if you're talking about temperatures, and that's an exam question about temperatures, draw yourself a little number line and just put those numbers where they are to work out the differences. Don't confuse yourself by subtracting or adding or whatever. I'm going to show you how to add, subtract, multiply and divide negative numbers next. But if you get a question on temperatures that's asking for the difference between two places, just try and do it like that and just nail the basics. Okay, I'll turn the lights on. So now we're going to do this properly. So we need to look at the rules of number with negative numbers. So if I just said a nice easy sum, 2 plus 1, there's no issue. And we know that this is a positive 2 and that's a positive 1. And before I had lots of signs everywhere and it was like, whoa, what's going on? So you all know that when you add a positive and a positive, 2 plus 1, so I'm starting at 2 and I'm going one space that way, aren't I? That's addition. So anything we add goes that way, and when we subtract, we go that way. And when I've got two numbers like that, it's not an issue. I know which way I'm going, don't I? Okay, right. If I said to you 2 minus 1, that's not an issue either, is it? Because I'm starting at 2 and I'm telling myself to go that way. Where the confusion comes in is if I say I've got 2, okay, the function is add, I want to add the number minus 1. All hell breaks loose. What the heck? That's the time when we become peacekeepers. We're going to resolve conflicts, okay? So I'm going to give you all the combinations for adding and subtracting negative numbers, and the way we resolve the conflict is through something called the Sine Rule. Anybody heard of the Sine Rule before? No? Yeah? What do we reckon the Sine Rule is?
It's when you minus and minus is plus and...
Oh, sort of, but not quite. Yeah, you're brilliant. Yeah, you're brilliant. It is that. Okay? When the signs are different, we subtract. Yeah, so I've got a plus and a minus, minus and a plus, it's a negative. When the signs are the same, we add. So that's our conflict resolution. Applies. Okay? So when the signs are different, you get a negative. And when the sign is the same, you get a plus. Essentially, that's the Sine Rule. Okay? Let's talk about when we use it. We use it in slightly different ways. Okay? The way we're going to use it in addition and subtraction is going to be slightly different to the way we use it in multiplication and division. Okay? So we're going to have conflicts every now and then, not always, that we're going to need to resolve when we introduce negative numbers. So let's go through all of these, but in a logical way. Okay? So if I say to you, when we're adding 1 plus 2, I want us to come up with a process for adding any numbers. So can you remember what I did first? What's the first number? What did I do with it on here? I visualised where it starts. So I'm starting there. And then I've got a function which is telling me to add, and I'm going to go 2 because I know adding is that direction, 2 spaces that way, and I end up with 3. Does that make sense? Yeah? So now, let's use that same process for dealing with this. Where am I starting? Minus 1. So I'm not starting there. That's my start point. So my first number is where I'm starting on my number line. And then which way am I going? Quite straightforward. Going that way. So I'm going 1, 2 places that way. So my answer is positive 1. Can you see what I've done there? So let's use our process again, but we've hit a confliction. So where am I starting? Positive 1, so I'm going to start here. Now, I've got an issue. I've got a process that's telling me to add, but I've got a number that's negative. What does my Sine Rule say is the outcome of my conflict? Brilliant. The signs are different, so really what that sum is saying is that. So I'm starting at 1 and I'm going 1, 2 that way, so that's my answer to this one. So that's minus 1, that was 1, that was 3. So let's do the same process over here then. Where am I starting? It's getting a bit messy, let's clean it up for us, because these are the tricky ones. Okay, so where am I starting? So if I visualise where I am, I just still really need to resolve which way am I going? Which way am I going? What's the outcome of my conflict? Minus, isn't it? So it becomes minus 1, minus 2. Well, I've got my start point. I've resolved it, so I know which way I'm going. Which way am I going? And I'm going 2 spaces that way. So I end up at -3. Yeah? And they're all the combinations that you can use. Anybody got a headache yet? Don't worry, you can go over this slow time. So, just to review it. I know if I've got a straightforward plus, I'm going that way. This is my start number. This tells me which direction, and then I either go a positive way or a negative way, okay? When you get negative numbers, that's your start point, you're starting in the negative area, and then based on adding, you go that way, subtracting, you go that way. And even now, in my head, I will visualise where am I starting, which direction am I going, okay? Let's do it again. So we've got our process. Visualise the first number in our problem, whether it's positive or negative. Is there a conflict to resolve? If there isn't, if it's telling you to add, just go that way. And if it is, resolve it. Okay, so if you've got a plus and a minus in there, resolve it. And then finally, add or subtract depending on the outcome. So have a go at those 3. So let's look at our process then. Let's introduce the process. Back, middle, righties. Where do I start?
-6.
So I'm starting at -6, and what am I going to do? Which way am I going to go?
That way.
So where do I end up?
2.
+2. Everyone happy with that? Everyone get that? Yeah. So you're visualising you're starting at -6 and you're going 8 that way. Let's look at this one then. 6 plus -9. Back lefties. Where do I start?
6.
So I'm starting at +6. What's the outcome of my conflict? So I've got 6, I'm taking away 9, and where do I end up?
3.
Sorry?
-3.
Good, -3. So if I go 9 that way, I actually end up here. Yeah? See what I'm saying? So it keeps you correct all the time. Let's do the last one. Where am I starting? Clean this a little bit. Fronties. So I'm starting at -3, and which direction am I going? Backwards, because I've got a conflict that says, my sine rule says, the outcome of the conflict is that. So if I'm at -3 and I go 4 that way,
-7.
everyone happy with that? Getting that? Woo! Yeah? Excellent. It's exactly the same for subtraction, okay? So addition and subtraction use this conflict rule in between here, when there's a conflict there, okay? So, the first one, a basic subtraction you could all do before you came in tonight. I'm starting at 2, and I'm going that way 1, and it leaves 1, hopefully. Yeah? Let's look at the conflict then. I've got a +2, so where am I starting? 2. What's the result of my conflict? Brilliant. I've got 2 negatives. I've got a takeaway and a negative number. A negative and a negative. So this becomes, which is, you're getting there. Okay. Let's introduce some more negative numbers then. Where am I starting? I'm starting at -2. And which way am I going? Yeah, minus. It just there's no conflict. It's just telling me go 1 that way. So the answer is -3. Happy with that? Let's do the last one at the end, which in theory is tricky. I have no idea why it did that. Let's just go back and forwards. Okay. Where am I starting? Yeah. So I'm starting at -2, and what's the outcome? I'm going to go that way 1, so I end up at... So that is adding and subtracting every combination of negative and positive number you can think of. Happy? Show me. Show me you're happy. Centres. Talk to me. Where am I starting? Starting at -3. Which way am I going? So it becomes... Brilliant. Everyone get -5 for that first one? Good, good. Second one. Front rights. Where am I starting? +5. Which way am I going? Good. I'm adding because I've got a conflict. So I resolve the conflict. I go +2. Oh, it's easy. You take maths with difficult. Right. Last one then. Hardest one. Minuses everywhere. Come on. Hey. Where am I starting? Which way am I going? Positive, good. How many? Which takes me to... If ever there was one to get right, it's the last one, because it shows you've learned something.
So we just ignore the bracket.
Right, the brackets, sorry I should have mentioned the brackets. The brackets, suddenly been introduced, are separating the number, which is -2, from the function, which is subtraction. Okay? So brackets are a way in maths of saying this is something on its own. Okay, and you'll see that. We're going to talk about brackets in a minute. Contain your excitement, please. Right. So now, we've done addition, we've done subtraction. Our rule changes slightly with multiplication. Because when we look at multiplication, the conflict here can't be resolved using the sine rule, because I've got multiplies and minuses. So the rule for multiplication and division applies to the numbers. So the signs in front of the numbers. So if I said to you 3 times 2, you all know what that is. You've been doing it for years. Thank goodness. Okay? If I say to you 3 times -2, good. I've got a positive number and a negative number. So a positive and a negative, according to our rule, is a negative. So resolve what the sign's going to be and then do the maths. 3 times 2 is... What's that? Negative, and a positive gives me a negative, and then just do the maths. 6. So look at the signs first, and then do the maths. Got a negative and a negative. 3 times 2, I've got a positive 6. So with multiplication and division, you're resolving the signs that are with the numbers. Okay, so it's slightly different from addition and subtraction. Addition and subtraction, we had a conflict in the middle. For multiplication and division, it's the conflict between our two numbers. That's positive and that's positive. So it's going to be positive. That's positive and negative, so it's negative. Negative and positive is negative. Negative and negative is positive. And then just do the maths. Okay? Let's have some examples. So let's look at our process first. Resolve the signs of whatever it is you're multiplying. Okay? So look at your two numbers. Have I got a positive or a negative? Whatever the outcome is of that is the sign that you're going to use, and then just do the mathematics. Okay? So let's do some questions then. Have a go at those, and we'll go through them together. So remember, they're all slightly different for multiplying and dividing. We're looking at the numbers that we're multiplying. Are they positive numbers or are they negative numbers? And if there's a conflict, you have to resolve it. So for the first one, -2 times 5. What two numbers am I dealing with? A positive and a negative, yeah? -2, +5. The outcome, therefore, is... And then 5 times 2. Yeah. So it's not about the maths, it's about the process. -3 times -6. Everyone got positive? Yeah, two negative numbers, negative and negative. Resolve it, it becomes positive. 6 times 3. Excellent. 7 times -4. What's the outcome going to be? Negative. Okay. And 7 times 4. Yeah. So we've got our process for multiplication and division. Sus. Yeah. Let's do it for division. So with division, if I do 6 divided by 2, I get 3. You've been doing that for years. Just two positive numbers, okay? 6 divided by -2. So remember the rule? I've got to look at the numbers. So the result is going to be negative, and it's going to be 3. -6 divided by +2. Good, because you've got a negative and a positive, so the result is negative 3. -6 divided by -2. Good, it's positive, and it's the number 3. Yeah? Everyone happy? Oh, that's a lot easier than I thought it was going to be. Yeah. Okay, brilliant. There's some divisions for you. So the maths it's not about the numbers, it's about the process. Let's have a quick look then. Ooh, I'll use black, I haven't used black tonight. So, -25 divided by 5. What's my process? What's my first bit going to be? negative, because I've got a negative number and a positive. So my outcome, before I've done any maths, is negative. Yeah. And then my quotient. Okay. Minus, because I've got a positive number and a negative. Is that an insect? It was. It's now a black dot. Okay. And the maths for it, the quotient. Okay, the last one. What's my sign going to be? What's my process? Excellent. Everyone happy with that? Yes. You've sussed the sine rule. I'm so chuffed. And this is just to show you, you will just get a question like that in the exam. They'll just say, do this, do that. Off you go, 2 questions, 2 marks. Yeah? Okay? We'll give it a go. Let's have a look at these. So what sort of numbers am I looking at then, Sarah? I've got 2 numbers here. So that's clearly what sort of number? And that one's a... Good, so I've got a conflict, haven't I? So my conflict resolution, my sine rule, what does that tell me to do with it when they're different? If they're the same, they're positive. If they're different, they're is the easiest way of remembering it. So they're different, aren't they? So whatever my answer is, it's going to be negative. And then there's some basic maths. What's 7 times 11? Good. That's your mark in your exam. So you've got the correct sign and the correct number. Let's look at this one then. Okay? I've got a negative number and a negative, so the signs are the same. My sign rule says when the signs are the same, they become... When they're the same, they're positive. Yeah? So my answer is going to be positive, whatever it is. And then I've got 72 divided by 8. 9 times tables. You recognise it. Yeah? Okay. So that's the first 2 objectives. Okay? Don't worry, the others will be faster. And we've got an hour to do them. This is the rule of maths when things start getting a bit more complicated. So if I'm going to do more than 2 functions, in other words, add and subtract more than 2 numbers, I need something to tell me the correct order in which to do them. Who's heard of it? Give me a B. What's the B stand for?
Brackets.
Brackets. So brackets take priority, and we talked about this earlier. When you see a brackets in maths, whatever's inside that brackets has to be done first. Ah, here we go. Kerry's favourite. Indices or order. Yeah? What did we call it last week? Power. Yeah? We can call it power if you want, but it doesn't go. That's why we call it BIDMAS or BODMAS, not BPMAS. Okay? But it is, it's the power. D and M.
Division and multiplication.
Right? And they're the same colour because they are at the same level. You don't do division first before multiplication. And a lot of people get BODMAS wrong because of that. What it means is they are done like you would read a book from left to right. So if you've got a sum like this, there are 2 possible answers to it. If you're left with division and multiplication, you do them, because they're at the same level, from left to right. So here, I would do 6 divided by 2, which is 3, and multiply it by 3 to get 9. Okay? I wouldn't do 6 divided by 2 times 3, which is 6, which gives me 1. You get the wrong answer if you don't do things correctly in maths. Okay? So, BODMAS keeps us straight. And what it says about division and multiplication is you do division first before... If you have just division and multiplication left, you do them from left to right. I'll show you this again with addition and subtraction. That's the A and the S. I've blown it for you, okay?
Peter,
Yeah.
would they ever put multiplication then division?
Yeah.
So you do the multiplication first, then the division?
Correct, absolutely. So if I said to you 6 times 2 divided by 3, do the 6 times 2 first. Because division and multiplication are at the same level, and when you're left with just those, you do them from left to right. Okay? We're going to do an incredibly complicated question in a minute, and you will all nail it first time, okay? Addition and subtraction is exactly the same. They're the same colour, because if you come across addition and subtraction, you do them like a book. You do them from left to right. So let's look at the 2 possible answers from that question at the bottom. If you get it wrong and you think addition is first, you would do 6 minus, do the addition, 6, which is 0. That's the wrong answer. Because I'm left with just addition and subtraction, I do them from left to right. 6 minus 2 is 4, plus the 4 is 8. That's the correct answer. So can you see, by not understanding the rules, you will get the wrong answers in maths. And that's why we have BIDMAS. It tells us the order to do things. The one that everybody gets wrong are these two. They're at the same level, and when you're left with just addition and subtraction, you do them from left to right. Okay. So just as a reminder, brackets, indices, division and multiplications from left to right, addition and subtraction, again, from left to right. Right. So let's do some together. Let's discuss some before I give you a really nasty exercise I came up with. Okay. So the first one, what are we dealing with up there? What are the functions that we've got? We've just got addition and subtraction. So what does our rule say that we have to do with addition and subtraction? Go from left to right. So the first thing I have to do is 4 minus 2, which is 2, and then add the 3, which is the correct answer. Notice if you did the addition first, because in your head you think addition is before subtraction, you'll get a totally different answer. Yeah? So addition and subtraction are at the same level. Next one. What do I do first? Good. Because multiplication and division come before addition and subtraction. So this becomes 5 minus 6, which is minus 1. I'm starting at 5 and I'm going 6 that way, so I go past 0 to minus 1. This is bigger than that, so it's going to end up negative, isn't it? Be careful of negative numbers. Okay. The next one, what am I going to do first? What's good? Because the B in BODMAS is the ultimate, the brackets. So I have to do the brackets first. What's inside the brackets? Good. And then I do whatever's left. Happy? Excellent. Last one. What do I do first, Kerry? The square bit. So you do the 3 squared first. So it becomes 9 plus 2 times 2. So what do I do next? Good, because the multiplication is next. So it becomes... So it's 9 plus 2 times 2. So you do the 2 times 2 first. So you get 4. 9 plus 4 equals 13. Okay, good. Here is an incredibly complicated line of mathematics, and we're going to break it down step by step and solve it. We are honest. So I've got 10 times 5 minus 4 plus 2 to the power of 2 plus 6 divided by 3. Sucks in the air.
Can you just say what the power is again, that little 2? What do you do with it?
It's an indices. It's saying whatever is raised to a power is that number multiplied by itself.
Oh, right.
So 4 squared is 4 times 4. 5 squared is 5 times 5.
Just times it by that.
And because it's a 2, you only multiply itself 5 times 5. We're going to come on to cubes in a few weeks.
Okay.
Don't worry. We haven't done that. Right. Okay, so that's my equation. What am I going to do first? Good. Because the B in BIDMAS is brackets. So it becomes 10 times 5 minus, I've done my brackets, 4 plus 2 becomes 6, squared plus 6 divided by 3. What am I going to do next? The squared. So it's 6 squared, so it becomes 10 times 5 minus 36 plus 6 divided by 3. What's next? What have I got left? Multiplication. I've got a multiplication. And I've got a division. So I do those first. So the first multiplication, so 10 5s are 50, 6 divided by 3 is 2. So I do 10 times 5 is 50, 6 divided by 3 gives me 2. Now what have I got left? Addition and subtraction. So I go from left to right. So I do 50 minus 36, which is 14, and that leaves me with adding 2. So the whole point of that question is it shows you the BIDMAS structure. It starts off with a bracket, then an indices, then division, multiplication, then addition and subtraction. BIDMAS comes with practice. I'm going to give you a number, a value. So I want you to place brackets on that particular card to give me that value, if that makes sense. Do you want me to talk you through the first one? Do you want me to give you the first one for nothing? So, for example, on card A, I want you to put some brackets onto this to give me the value of 19. Okay? So how do I get 19 from that? Just to show you how it works, brilliant, they've got it here. Okay? Don't be frightened of marking the cards if you want to. So what I'm after for this particular problem is that. So you're forcing it, because you're using brackets, to do 4 times 3, which is 12, plus 2, 14, plus the 5, 19. Here is an example of how they're going to check your understanding of BIDMAS. This is a pretty standard example of what they might do. So Ben's working for the calculation, 12 plus 4 times 10. So what he's done is 12 plus 4 is 16, 16 times 10 is 160, and he's given the answer 160. Ben is wrong. Work out the correct answer for 1 mark. So you could actually just write the answer on that answer line, but you might want to show them the correct way of doing it. What you need to be doing is saying, why is Ben wrong? What's he done wrong there, and what should the correct answer be? Nicole just said he did the addition first, so for the correct answer he should have done 4 times 10 first, which should give him 40, add the 12. So for your 1 mark, which is a bit rubbish really for an exam, get 52. We're going to finish off about 10 minutes with these powers, approximating powers and places and stuff, okay? So what we're going to talk about for the next 10 minutes, and then I'll give you a task here, is rounding, okay? Rounding is really, really important. It gives us kind of an estimate of what our answers are going to be, okay? So, we're talking about rounding integers. I'm not talking about rounding decimals and other things you might come across. We're just going to keep it on integers tonight. And there are 3 main ways of rounding. Rounding to the nearest 10, 100 or 1,000, an estimate of a value they might ask for, or something called significant figures. Now whenever you're doing any of those 3 processes of nearest, estimating or significant figures, there's a golden rule. It's a number, okay, that dictates what you're going to do. Anybody tell me what the number is? 5. And what do we do when we hit a 5? Brill. So I always have this image in my head. Whenever I have a decision that rests on a 5, I round up. If it's 6, it's obvious you go up. If it's 4, you go down. But when people hit a 5, they're like, so just an image of the number 5 floating up. So if you hit a 5 on your decision, you round up. Okay? So let's look at the 3 techniques then. So why do we need to round? Well, we need to know that the answers we're going to give are going to be in the right area. And hopefully when you're doing Unit 2, because you haven't got a calculator, you want to know that your answers are of the same magnitude that you're looking for. So earlier on tonight, we did this question, 42 times 35. Some of you, hopefully, have got the answer to that written down exactly. Okay, I can't remember what it is off the top of my head. But I can tell you that if I round it to 40 and 40, I know I'm looking for a value of around 1,600. So it's going to be something less than 1,600, but it's going to be 1,000 and something else on the end of it. So if I did my calculation wrong and I got 150 odd or 150, I know that I'm in the wrong magnitude. So a good use of rounding is to check your answers. Are you in the right magnitude of answer? Okay. So let's look at the first 3. Okay. John has 123 people coming to his party. Write this number to the nearest 10. What do we got for that? Good? 120? Everyone happy? So, to the nearest 10, so we're looking at this, we're interested in this. The next one along is a 3, so we round down to 120. Attendance of football match, 2,568. Preston on Saturday, just about. Okay? Rounding that to the nearest 100. Everyone got that? So, I'm interested in the hundreds. I make my decision based on the next one along, which tells me to round it up. So it's 2,600. Good. And then the last one, population of Ulverpool is 452,529 to the nearest 1,000. So I'm interested in the thousands, so what does that round to? 453, because my decision is based on that, so don't forget the thousands, put the zeros in, okay? Happy with nearests? So near, so far. Significant figures then. When we're talking about significant figures, what is the most significant figure on that number, do you think? When we talk about significant, what is the most significant figure? 3. Good. Can everyone see that? It's the most important number because it's the first, it's the biggest order of magnitude. So if I said to you, round that number to one significant figure, what am I interested in? The 3. And what is my decision to round up or down based on? Good. So it's based on the 6. So that's what it's based on. So where would I go from 3? And then I'd substitute everything else with zeros. So that's one significant figure. Everyone happy with that? Let's look at 2 significant figures. You won't be given anything more than 2 significant figures in an exam. Okay? So I've got a big number and I want to round it to 2 significant figures. So what number is my second significant figure? Good. So this time round, I'm interested in the 6. Do I stick or twist? What's it based on? Good. The next one along, the 4. So what does 36 become? Stays at 36. Trick question. And don't forget your zeros. Estimates. If in an exam paper they give you an estimate, that's what they want. Let's have a look at the first one. iPad costs £419, £21 a month. Estimate how many months I need to save. So, 419, what should we call that then? Okay. And 21 months, what should we call that? 400 divided by 20, is that hard for anybody? The way to do divisions when you end up with lots of zeros is they cancel each other out. So 400 divided by 20 is exactly the same as 40 divided by 2. We haven't done that as a tip yet. So it should take 20 months. Second one then. Jill writes 21 times 19 equals 4,000. Is she correct? So we're just checking her answer, like I hope you will start doing with your estimates with your homework. So 21, what should we call that? Times. So when we do the maths now, and we've got a technique for dealing with these zeros, get rid of the zeros. 2 times 2 is, stick the zeros back. She's wrong. Okay? And that, ladies and gentlemen, is, in 2.5 hours, lesson number 1. Buzzwords. There is a glossary of terms on my course. I'm not going to complete it for you this year. Last year I was the one that was entering all the information. I suggest you go through what we've covered tonight and pull out relevant words you'd like to see in there and start populating it with your definitions. Words you might like to consider are integer, sum, difference, definitely product, forget about quotient, but you never know, okay? Resources, what's available to you? Well, when you enroll to my course, you've got tonight's lesson slides, so you can go back and take your time and look through stuff. You've got additional worksheets, so if you struggle with BIDMAS, the Sine Rule, long division, multiplication, there are additional sheets in there to help you. They've got the answers with them. It's not a test, I'm not trying to put you under pressure, I'm trying to improve your basics. Topic-specific notes are in there, and by Sunday, though it gives me 5 minutes to myself, I will create a video of tonight's lesson based on what's happened up on this board. Okay, so again, that's another opportunity to go through things at your own pace and slow things down.